Alright, so as you guys just told me, the two variables are distance and time. So whenever we go outside, about half of you guys will have stopwatches, right? So I'm going to pull out the project, I'm going to yell your name, and we go 3, 2, 1, and everyone with the stopwatch is going to time how long it takes to hit the ground. Then, if it's your project, and you're going to have a data table for all this, if it's your project, you're going to go to 3 people around you with a stopwatch and record whatever time they have. Okay? That way, whenever you average it, hopefully that will get rid of some of the outliers, either stopping too late or too early or whatever. So that takes care of our time part. Now, distance, however, we need to determine a different way, because we can't just use a stopwatch for distance. So how are you going to figure out the distance of travel? What?
Measure the building.
Measure the building. How are we going to measure the building?
Meters.
Oh, yeah, free
climb
fall.
out. Throwing meter sticks.
Free fall distance?
Free fall. Okay, well, the free fall distance would work if we didn't have to deal with air resistance. So those, when we calculate free fall, we were calculating that without air resistance. And that was a perfect world basically in a vacuum. This, we will have air resistance, and hopefully air resistance works to your favor, right? Because the more air resistance, the slower it's going to go, and then the softer it's going to hit. So meter sticks would be fine if you could scale the wall. So that's not going to work. How else?
We could
A giant ruler. Measuring tape?
Okay. Measuring tape, if we had one long enough, which I don't.
we could measure this room times 4 because there are 4 floors.
Okay, measure this room times 4. That's not a bad idea. That'll get close.
Ratio.
What kind of ratio? Proportion ratios? I think you guys are fishing. That's exactly right, Mitchell. We're going to use our trigonometry.
Oh, God.
Right?
What?
I love trigonometry.
I was going to say it this way. Just count all the bricks.
Measure one brick and then count how many bricks. That would also work.
That makes sense.
But we're going to use trig. So the first thing I want you guys to do is get out your calculator. And before we get into doing any calculation, let's make sure that all of your calculators are in the right mode. Okay, because they have to be in degrees. Because if it's in radians, then you'll get the wrong value. So here's what you're going to do. We're going to use tangent. So if you notice, you have the sine, the sin, the cos, and the tan. Okay, those are your 3 trigonomic functions. So hit tangent of 45 and hit enter. See the tan?
Okay.
Hit tangent 45 and hit enter. And what do you get?
1.
You get 1. Does everyone get 1?
I see.
Not 1.
What?
Yes.
Well, hold on. No, it should just be.
Well, he's got the weird.
Yeah, it's on. Right there, below table.
No.
Okay. So this one you just Alright, so everyone got 1, right? No one got 1.6 or anything? Okay, good. That means everyone's in degrees. So our variables are as follows. Okay, now what type of geometric shape are we using?
Triangle.
With Mitchell? What kind of triangle?
Right triangle.
A right triangle. Okay? It has to have a 90-degree side. Okay? So our variables are adjacent, opposites, and hypotenuse. Okay? Now all of these are in relationship to theta, which is our angle. Okay? The angle that we measure. Everybody have these? Yeah.
No, I am.
So, depending on which function we're going to be using, will determine which of these we actually use. Okay? Now, for our purposes, we're just going to use tangent. Okay? We're just going to use tangent. So, and don't feel intimidated if you haven't used these in geometry before, or whatever. It's real simple. Basically, all it is an extra button push on your calculator. So for tangent, anyone know the variable or the equation for tangent? Mitchell, you raise your hand again.
Opposite over adjacent.
Okay, what is opposite over adjacent? Jimmy Fist III, did you have a?
No.
Blake, what do you think?
The opposite side over the adjacent side of the triangle.
Equals what though?
Equals height.
You're giving me half an equation. Jimmy Fist III?
Is it the tangent of the angle in question?
Equals what? Okay, I'm getting a half from you and a half from you. So is someone going to put it all together?
But you say yours means you should use something.
What did you say?
Mitchell, you going to save us in this terrible spot of blankness?
The angle that correlates between the two sides.
Jimmy Fist III, what did you say?
The tangent of the angle in question.
Equals?
Opposite over hypotenuse.
Thank you. Opposite over
Adjacent.
adjacent. So, if we in fact are looking at a tree and all of a sudden wondering, how tall is that tree?
Oh, I think.
You need to know two things if we're using tangent. We need to know, well, what are those two things? What two things do we need to know?
Distance and time.
Distance.
And
Distance from the object.
Shadow?
And the,
Line of sight.
Shadow?
okay, close. We're looking for the height.
distance that you're away from it, and distance how tall. Just getting that expression.
Distance off your finger.
The angle. That's right.
Yeah.
So if we know the measured length, basically the distance from the object, and if we know the angle to the top of the tree, okay, then we can calculate the height. Okay?
Wait. But that's only
But that's only what? What were you going to say?
like half of it.
Okay, so what do we have to do for the rest?
Well, you add that times 2? Like,
No, because it's not actually half, but it's...
You add your own height.
Yeah, you have to add your own height, right? To your eyeball.
Oh. I get it.
So, everyone, of course, is drawing this beautiful drawing. We're going to say for our purposes that our guy is 1.50 meters. Okay, so that's what we're going to add on to the end of our calculation. Now, also, where it says measured angle here, that's somewhat of a misnomer. That's not actually labeling your hypotenuse. That should be, if you want to be technical, it goes from right there. That's our measured angle.
You don't need to.
So, dealing with our variables, our hypotenuse, what is our hypotenuse? Which side is our hypotenuse?
It's the measure angle.
Okay, it's the side that says measured angle. It's our hypotenuse. We have our adjacent, which is our base, right? And then the unknown length that we're finding is our opposite. What was our equation again for tangent?
Tangent of the angle in question equals opposite over adjacent.
That's right. So are we dealing with hypotenuse?
No.
With tangent? No. We're only dealing with opposite, or looking for opposite, using adjacent and our angle. So, our equation. So I was finishing their beautiful drawing.
Just to like tell you the equation.
Now that's our next slide. Is everyone done? Moving on. So, our equation is as follows. Tangent of theta equals opposite over adjacent, just like you told me. Now, if I were to put this in an equation triangle, what would go on top? What? Yeah, opposite. Our O is going to go up here, and then it doesn't matter which one we put in the bottom, right? We're going to do. Ooh, it's thick. Tangent of theta there. And adjacent there. What are we looking for?
That's it.
We're looking for the height, right? So we're looking for our O. So in that case, if we manipulate this, O is going to equal what?
The tangent times the adjacent.
That's right. Tangent of theta, do not forget your angle,
Oh, yeah.
times your adjacent. That's our equation. All right. So you were measuring the angle and the adjacent, right? And we'll talk about how we're going to measure the angle tomorrow. Find our opposite. Now, in our example of the tree and the guy, we're going to figure out that the angle is 40 degrees and he is 100 meters away. Okay? 40 degrees is the angle. Is everyone done with this? So label your measured angle 40 degrees and your adjacent is 100 meters. Degrees, 100 meters. I want you to calculate your opposite. Calculate your O. So just plug it into your equation. Found an answer? Plug it in and make sure you get the same answer as I get. so you know that you're using your calculator correctly. All right, what do we get? Just leave.
83.91 meters.
Yeah. Is that our answer?
Yes.
No.
No. What do we need to do?
We need to
Add your height.
Add your height. Add the guy's height, right? So we're going to add in the 1.50 meters.
Also, is that how tall you?
Yes.
Now,
Now, obviously, when you do this tomorrow, what are you going to use for 1.5 meters? Your height in meters. Okay. And what do you guys get?
85.4.
Woo! 85.4 meters. Questions on that? Good. Try this one. What? Anisha, did you need to see the previous slide? It's in centimeters, right? So what do you need to do? Convert. You can either convert at the beginning or convert at the end. It doesn't matter.
Using the same.
25th, third. Do you have a good answer?
I think I do, possibly.
Is it the right answer or is it just a good answer?
Either, maybe.
Max, your question?
do we add height? Like,
Yes, and use the same height. No. Yes. Now, I went the long way and I converted the height to centimeters first. And then I added it together and then converted to meters. But you get the same answer. Questions on that?
Yeah. You made it to meters first. How would
Then it would just be 14.91 plus 1.5.
14.9? I definitely didn't get that. How did we get 14.9?
You do, so tangent 55 times 10.44. Right? Now we'll get 14.9.
Oh, I still not
Show me what you're putting. Tangent, no.
Oh,
Tangent.
that's
There's your problem.
Yep.
And then you add your 1.5 to your height.
I got 0.
What? 0?
55
Tangent of 55. You hit tangent first, right? And 55, close parentheses.
Oh, there's no.
Yeah, depending on your calculator, you do need to close the parentheses. It's just a good idea, guys, to close parentheses every time.
Okay. So I got the wrong answer.
All right, now, is the opposite here, is that the height that it's going to be falling? That the distance is going to be falling?
Yep. No.
As I throw it off?
no,
No.
it's going from your head.
Okay, but it's not going straight down, is it?
Air resistant.
Which way is it going?
Angle.
It's going out at an angle. Okay? It's the hypotenuse. Now, whenever you guys measure the angle, when you measure this angle, where are you going to be standing? Or where should you be standing?
On the wall.
Where it landed. Right?
Yeah. Sorry, I thought you meant like while you were throwing it.
So, because you're not going to know exactly where it lands, because we're going to be doing this tomorrow. We're going to be calculating tomorrow the distance. I'm going to be aiming for a particular area. Okay, I'll get close, depending on the weight and the air and the wind and the air resistance and everything. So I'll show you where that point of impact is, and that's where you're going to find your angle. Okay. So now that we have two of our sides, we have our adjacent side and we have our opposite side. What can we do? How can we find the hypotenuse? That's right, by the Pythagorean theorem. So, using this example, I want you to find your hypotenuse. Using those numbers that we just used. And obviously you want to use your distances in meters.
Do we use the height? Do we use the height that was used after we added the height of the first one?
Yes, the height that you use is going to be total height. So for B, if you call adjacent A, then B, use that as the total height with the person.
So A is the adjacent and B is the total?
Is the opposite with the, yeah. Or it doesn't matter, right? B could be the adjacent and A could be the total height. And how do we get rid of a squared variable? Mitchell, you think?
Are you,
Square root?
yeah.
So if you're radical it?
That's what Miss Henry says. Radicalize it.
So square root of 378.
Going.
19.4. I agree with that. 19.4 meters. Any questions?
What's the
Why is not
Why is it what?
so important?
Okay, so why did we just do that?
Because that's the distance it's going to be traveling.
That's the distance your egg drop's going to be traveling.
So my
If these were the correct angle and distance from the wall. Okay? So tomorrow, you're going to go out and we are going to do some calculations on 4 different objects. Okay? Actually, 3 different objects. One of them is going to be in here. Start off in here. And you are going to find angle and the distance from each of these objects and calculate them. Calculate the height of the object and calculate the hypotenuse. Using this data table. This will be used both tomorrow and day of the egg drop. So this contains all of our data. Yes? Okay, what? So I want you to copy this down. Anisha, I'll be with you in a second. I want you to copy this down landscape and make it the entire page.
Thank you.